The very first game I ever played on a PlayStation was Tekken 3. Fighting games have always been fun for me, so naturally, I wanted to build a fighting game template of my own. The first thing I needed to tackle was the AI. My initial idea was to write all the AI logic directly inside the AI character blueprint, but that quickly felt clunky and hard to maintain. I decided instead to use Blackboards and behavior trees. To be honest, the first time I tried this approach in another project, I was completely lost and ended up abandoning it. But now, I'm a bit older, a bit wiser, and it finally makes sense. So in this video, I'll walk you through how I structured a simple fighting game AI using Unreal's behavior tree system. Let's dive in. The AI character, shown here in red, is simply a copy of the default third-person character. I removed the camera and all related camera logic from the blueprint. I also added a nav mesh bounds volume to the level. This allows the AI character to navigate and move within the environment. To keep things organized, I split the AI logic into three main folders: the brain folder, the bridge folder, and the eyes folder, which honestly should have been called the sensory folder. Each folder has a specific responsibility, making the system easier to understand and extend. First, let's set up the brain. This is where all the AI's decision-making happens. It's composed of two files: a Blackboard, which acts as the AI's memory, and a behavior tree, which is the actual decision-making logic. Inside our brain folder, we have our Blackboard, named BB Fighter AI. This is where we'll create variables, or keys, to store vital information. First, an object key called target actor, with its base class set to character. This tells the AI who it should be focusing on. Next, a float key called distance. This will store the distance to the target, helping the AI decide when to attack or back away. Then, a bool key called player is attacking. The AI will use this to decide if it should block. And finally, another bool called is guarding, so the AI knows if it's safe to attack. With our memory defined, we now have the behavior tree, BT Fighter AI. We'll come back to build the tree's logic in a moment. Next is the bridge. This is a blueprint interface called BPI Combat. Its only job is to allow our brain, the behavior tree, to send commands to the AI's body, the character blueprint, without needing direct access to all its internal workings. Inside our interface, we'll create a single function called execute action. We'll add one input to this function, action name, which is of the name type. That's all we need here. It's a simple, clean communication contract. Finally, we have the eyes, the AI fighter controller. The controller's job is to possess the AI character and, most importantly, kickstart the brain. In its event graph on event begin play, we simply add a run behavior tree node and select our BT Fighter AI. Now, when the AI spawns, it will immediately start thinking. Okay, let's build the actual thinking process inside our behavior tree. First, our AI needs to know the distance to its target. For this, we'll create a service. A service is a node that runs continuously, updating the Blackboard. In our behavior tree, click New Service and name it BT Service Calculate Combat. Inside this service, we use the Event Receive Tick AI node. We'll get a reference to our player character, plug that into the other actor pin of a Get Distance To node, and the controlled pawn into the target pin. We then take the return value from Get Distance To and use the Set Blackboard Value as Float node to update our distance key on every single tick. We'll make the key selector a public variable so we can easily assign it in the main tree. Now back in BT Fighter AI, let's build the tree. From the root, we'll add a selector node. A selector tries each of its children in order until one succeeds. Inside this selector, we'll add our BT Service Calculate Combat service, and in the Details panel, we'll assign the distance key we just created. Now the AI is constantly aware of the player's distance. Next, we add a sequence node to the selector. A sequence executes all of its children in order. We only want this sequence to run if the player is close enough, so we'll right-click and add decorator, then Blackboard. In the Details panel for this decorator, we'll set the Blackboard key to Distance, the key query to is less than or equal to, and the value to 210. This acts as a gatekeeper. The AI will only proceed with the actions inside the sequence if it is within 210 units of the player. Now for the action. We'll create a new task called BT Task Play Action. This task will be responsible for making the AI attack. Inside, we start with Event Receive Execute AI. We get the controlled pawn, and from that we call our Execute Action function from the BPI Combat interface. For now, we'll hard-code the action name to be Kick. Finally, we call Finish Execute to signal the task is done. Back in our behavior tree, we can now drag our BT task play action into the sequence. Since animations take time, let's add a wait node after it, set to a short duration like 0.5 seconds, and then a finish with result node to tell the tree to restart its logic from the top. The final step is to make our AI character listen to the commands from the behavior tree. Open your AI character blueprint. In Class Settings, search for Interfaces and click Add. Select our BPI Combat. Now you can implement the Execute Action function as an event. Inside this event, we'll simply add a Play Montage node and select our Kick animation. We can use a Switch On Name node here later to handle different actions like punch or block. One last thing, in the AI Characters Details panel, search for AI Controller class and assign our AI Fighter controller. And that's it. Press play. You'll see the AI tracks the player, and when you get within 210 units, it will execute the kick action. We've successfully built a clean, modular, and expandable AI system. And that's it. You can find the link to the project, including all the fighting animations, in the description. Thanks for following along.